Hello everyone, this is Andrew Knight from RICS on this episode of our RICS Tech Partner Series. I've been with RICS for over 10 years now, and I work in the standards regulation and thought leadership part of the organisation. And my role is to look at the whole effect of data and tech right across the built and natural environment as it affects the profession. RICS, as you know, is a global body with over 130,000 members working right across the real estate life cycle in all types of assets, residential, commercial, mixed use infrastructure. So data and tech has a key role to play, not only in the technical aspects of our members' business, but also more generally in terms of the way technology will be used, the way they run their businesses. Now, today I'm very pleased to be joined by Emre from Holistic AI. So please do come on board, Emre, and really just to introduce yourselves and your organisation to the listeners. It'd be great to hear about the background of Holistic AI, where it came from. It came from in terms of coming out of that UCL background, and really the teams and skills and experience of Holistic. So over to you, and you're very welcome.
Thank you, Andrew. I really appreciate the invitation. It's great to continue this conversation because we've been having conversations for some time now. So just by way of an introduction to Holistic AI, let me give a bit of a background. So what we do as a company is we provide let's say, trust at scale for the use of algorithms in business, in government, in any kind of application. And the way in which this company emerged was through our research at University College London. So the two co-founders are myself, Emre Kazim, and Adriano Koshiyama. And we met in the computer science department under the kind of patronage of Professor Philip Trevelyan, the patron saint of all things innovation. And what we were doing was, Adriano was working on algorithmic assessment. So what's happened over the past even 20 years, I suppose, is there's been the steady development of algorithms and application of algorithms. And I use algorithms just as a kind of looser word than specifically AI to include things like machine learning and other kind of methods. It's just the kind of broadest use of the term. And these systems are being used in industry and being used in different applications. And in the last, say, 10 years or so, the use of these systems has radically increased. Reasons for that are things like different availability of data, developments in certain technologies, etc. So the use of these systems have really moved out of very small niche specialist applications into kind of broad general application. So in that context, what was a kind of research project for us? So the group was in financial computing, and we were looking at, in terms of the legacy, there was the use of algorithmic trading systems and then fraud detection of those algorithmic trading systems. So in a way, you can think of that as a kind of preamble to general algorithmic assessment or control or monitoring. And we started to look more broadly at just algorithms generally in different sectors and different areas. And a lot of our work was initially focused on government. So we were very interested in the legislative debate, the regulatory debate, and we were interested in government digital transformation. That was a lot of language was being used. A lot of these terms were being thrown around, especially about 5 or 6 years ago. So even though I'm not a computer scientist, I think I may have been the only philosopher, where I did my PhD in philosophy in the computer science department as a member of staff. Everyone else was an engineer. And we were very interested in actually solving this problem of, let's call it, algorithmic assessment. And the big kind of move was, how can we take frameworks or scientific research or engineering literature and actually make this useful or actually do this? So the language that was being used was operationalizing AI ethics or operationalizing AI governance. And in order to do that, we had to take a very interdisciplinary approach. So that's where I came in with policy, legal, ethics background. The engineers were coming in and looking at things like, it could have been, how do you do an actual tangible assessment? What do you assess, et cetera, et cetera? And we'll talk about that when we discuss the kind of reference paper. And the second part of, aside from the interdisciplinary, the second part was, we have to actually go and find out how this works in practice. Because there was like a zillion ethics principles, lots and lots of ethics frameworks. Everyone was publishing in this space and, opining about what the best way to do AI governance. The language started to change as well. And what we were very interested in is tangibly, any kind of assertion we make or any standard that's put out there, can we actually test it? Is this useful in practice? So we're very much empiricist approach to these problems. So the company, in a way, it kind of came out organically from our research, our attempts to apply this in public services. And when we started, because we were empiricists, we were looking for case studies. As soon as we kind of pivoted and started to look at industry, we saw much more engagement, more willingness to actually give us access to systems and start to actually test these systems, etc. And if you will, the long story, we'll probably come back to it right at the end, is what we do as a company is we have a platform as a service. We have a kind of scalable AI assurance tool, which is, you can do your risk assessment, you can do your mitigation of risks that you've identified, and then you can kind of come to some kind of sign off, or like report or some kind of a way in which a third party, it could be a regulator, would be able to say, okay, this has been sufficiently assessed and assured.
Well, that's great. Now, you referenced that paper that you put out, and it's quite a few months ago now, isn't it? And I've already posted a link to that on our RICS Tech Partner blog, and I'll make sure we'll post that link again with this interview. And I know it's a long and in-depth paper. Can you summarize it, if that's possible, in terms of the key themes that paper looks at?
So just at a very high level, it's the reference paper now, it's emerged as the reference paper for algorithm audit. So what do we mean by algorithm audit? Audit is a much more specific and very tangible, and you might venture to say objective or third-party way of analyzing a system in a systematic way. So the paper was a kind of event, if you will, in our space, which was to say the way in which we're going to solve this problem of trust is through some kind of, or at least in part, through auditing. So the paper was very much about algorithm auditing. And the way in which we position the paper is to say that, look, there's lots and lots of use of algorithms in industry, in government, etc. We've got lots of examples of high-profile harm. So Amazon had a recruiting algorithm which was purportedly biased against women. There's lots of examples from criminal justice of algorithms that were used to decide sentencing, which were kind of horribly racially biased. And there's like plenty of examples. So let's say in this particular context, you've got housing associations and other people doing housing, social housing, use algorithms to determine, say, housing allocation, etc., which are also biased. So there's lots of these high-profile cases of harm. And our, if you will, solution to that is to say, okay, these systems have to go through some kind of audit. And it's a kind of akin, or we try to make an analogy with financial audit, to say that, look, companies should be able to do these kind of assessments against some kind of objective standard and should be able to report these in a way which is satisfactory to anybody who wants to have a look. So the big question is then, what is algorithm audit? And what we do is basically, if you will, in two broad ways, map out the space. The first way in which we map it out is to say that all of this is effectively governance, AI governance. And we kind of divide the governance into, let's call it technical and non-technical governance. So the non-technical governance, let's start with that, is things like articulating your AI ethics or your general data ethics principles, putting in structures of reporting, accountability, allocating those responsibilities, and so on and so forth, having a report at the end and standardizing of that report, etc., etc. Let's call that the kind of non-technical side. Now, there's a lot of work in that space. We talk about that work right at the end of the paper when we discuss things like certification. We talk about things like insurance, what's the consequence on insurance, and so on and so forth. But the kind of heart of the paper is actually the technical side of the audit. And there, we do a number of things. We map out, or we try to systematize what a kind of audit would look like. So the first thing we do is we say, okay, first, what are you auditing? What are the parts of the system that you're auditing? And we look at data, we look at the processes, and we look at the use, the deployment. Then we look at what are you actually assessing specifically? And then we draw upon this is from the kind of literature or the best practice literature. We talk about 4 particular verticals. The 4 verticals are explainability, where explainability in the context of an AI system is to say, okay, is there a way for us to assess how this system came to its conclusion? I'll return and maybe speak a little bit more about that with respect to kind of access and levels to a system. But explainability, being able to audit how explainable a system is. So that's the first one. The second one is, and these are in no particular order, is robustness. So robustness is a lot of literature in this space, and most data scientists, when they think that they're doing an assessment of a system, think that they're assessing the robustness, where robustness is taken to be the performance of a system. So does the system, is it good? You know, is it accurate? Does it actually perform in the way in which it's supposed to perform? But then there's other aspects to robustness, things like how liable to an attack is the system, how vulnerable is the system, how secure is the system, how reliable is the system, how repeatable is the system. What would it take to kind of, I think the example that Adrian always gives is, if we were doing a facial recognition system and you put a plaster on someone's face, would it throw the whole system off? You know, just how, so there's different parts to robustness, but robustness is very central. And maybe when we talk about when we've actually done these audits, what we found is that everybody's interested in that. Actually, it became the kind of almost the primary form of assurance or audit. So that's the second one. The third one is bias, and that's probably the most high-profile case. So what do we mean by bias in an AI system? This is a very, very contentious problem, because you'd have to define bias in the first place in order to say that a system is biased. So let's take an example of in a marketing system. The whole point in a marketing algorithm is to target particular groups. So you want it to be biased in that respect. So we should talk about good bias and bad bias. So in that context, it could be that you're targeting a particular gender, which is fine. There may be a particular product that's specific for a particular gender. But then you might say, is it appropriate to target, let's say, particular demographics within that gender, and so on and so forth. So then the issue of bias comes about. So the first thing to say is you've got to define bias in order for us to come along and say, hey, this system is biased or not biased. Now, I won't go into the details of it, but happy to expand if need be. There's lots and lots of like standards of bias that we can test against. The best example of this is in the labor laws that came out of the United States, where they actually give specific numbers of when you compare different demographics to say if it's fair or acceptable or not. So let's say when we do the bias assessment, suffice to say what we do is we run standard bias tests. We're not here to say this system is biased or isn't biased, etc. We'd have to define that and then test accordingly. So that's a very important point. So that's the third one. And the final one is privacy. So I've got a particular interest in this space, because I think theoretically it's the most interesting, but in practice it's the one that we've had the least interest in, funnily enough. And I think the reason for that is because of GDPR, and companies are like, listen, we spent God knows how much money and effort, just don't come to us with new and exotic, privacy issues. But at its core, AI privacy in the context of AI is different to privacy in the context of general data governance, which is typically more about kind of the security of the system, respecting the kind of access to it and so on, permissioning. In the context of AI, it's things like you could use a system that's to satisfy GDPR or is private in the data governance sense, but just by using an algorithm, you can infer certain things about the data set or the data point. So it opens up and introduces different forms of privacy issues in the context of AI. So that's the fourth vertical, Andrew. So we just talk about different parts, and then we talk about what we assessing. Sorry.
That's brilliant. It's interesting that point about GDPR, because I think it's almost been a negative force insofar as people think that if they're GDPR compliant, they have sorted all their privacy issues, or indeed all their kind of issues around any level of kind of data governance. And I think it's been a bit of a negative force in making people think that because they're GDPR compliant, that's gone away. And I guess that's just one quick question on that theme of GDPR and the Brussels effect. What's your reaction to the draft EU directive that's come out around their views on a kind of a risk-based approach and almost applying a CE badge or label to algorithms?
So Andrew, I've seen a lot of commentary, and a lot of the commentary has been quite polemic. And I want to take a different position, which is I think the EU should be given a certain amount of deference just by virtue of the fact that they're a first mover and they forced the question. So I've got lots and lots of criticisms of the proposed legislation, and I can discuss them. But let me just start by saying, you know what, well done. Like, as in somebody actually put a mark in the, someone put a mark down and said, okay, here's our goal at this. And I certainly respect that. I think they've taken a risk approach, and I think that risk approach is very good. I think it's a healthy way of doing this, which is very different from GDPR. I think so they define different tiers of risk. The highest risk is just forbidden. Then there's high risk, and then there's like medium and low risk. And the systems that are forbidden are things like, I think it's social scoring, which is a kind of jab at China. It's just a differentiator. And then, which is interesting for me, because in the private sector, the social scoring is in a public sense, in the public sector forbidden, but in the private sector, can you create a persona of an individual using different data sets? I think you probably could, and a lot of companies do that, and that seems to me a kind of social scoring. But putting that aside, the other areas are things like facial recognition or biometric identification at a distance. So that's like scanning. But then they have all these exceptions for law enforcement, which is the only interesting part about it.
Yes.
And the third area is about manipulation. And again, like the whole of marketing is.
Yeah, I know there was a specific example they used around manipulating children, wasn't there? So it is, that it's quite a strong word, manipulation, isn't it? So.
Yeah, I mean, they actually do two tiers. They say manipulation of vulnerable, so that's children, elderly, disabled. And then the second tier is significant subliminal. They use the word subliminal in the legislation, manipulation of kind of said adults.
Yeah.
I don't know. Let's see how.
What is that you say? It's very early days, and credit that they've actually been, early adopters of saying, look, here's a potential framework. Let's work and develop on it. It's good to have got out into that space early, I think, hasn't it? So. Well, that's great. Going back to as you alluded before, that out of that paper, out of your work, you have now developed this risk assessment governance platform. Tell us about how that works and how you're using it. And
so, just a quick kind of transition from audit work to the platform. So, lots and lots of companies are interested in auditing a particular algorithm. They want to know that let's say in the context that we're talking here, they want to know that their housing allocation algorithm is fair or debiased, etc. Fine. So we can do an audit. But an audit is very, very strenuous. It's expensive. To do a proper audit on a system where we have access to code and to data and code, etc. Take a month and so on. So we were doing lots of audits, and what we've realized is, look, the first thing you need to do, what we're really interested in, is a risk assessment that doesn't require esoteric knowledge of machine learning. That's what the kind of executive is interested in. They want to know where's the risk. So what we did in the form of the platform is to say, okay, you can do at the first level and the surface level, you can just do a risk assessment of the system, which is just by answering some questions. So the first level of the platform is someone that comes on and they just start putting some basic information in. So what's the name of the system? What's the business case for the system? What's the kind of technology stack, and so on and so forth. And then they answer a series of questions, which is just 7 questions. And those questions map the risks that I described in the paper. So things like privacy, explainability, bias, etc. But without asking, is there a bias risk? You know, and then
Yeah,
the
yeah.
questions are structured accordingly. And at the end of that, and this thing should take no more than 10 minutes, 5 minutes indeed, to be able to do that. And someone doesn't have to have total knowledge of the system. They don't have to be the data scientist. So then they do that risk assessment. And at the end of that risk assessment, we flag, if you will, the risks. So there's the overall risk, and then we say, okay, the pressure points here, the risk areas are, there's an issue of bias, or there's an issue of privacy, etc. So we just identify the risks, and then accordingly, we provide a kind of pathways to mitigate those risks. So it was what's the point in identifying problems if you don't know what to do with them? You don't want to just have a risk assessment that says dump every system that has risks. So that's a big part of the system. The second part is to say, okay, we've identified these risks. Now let's go to the second layer, and this becomes a bit more technical. And we just give them kind of pathways to mitigation of those risks, or sometimes as basic as saying, okay, maybe we've identified that bias is a risk, and maybe they have actually already got systems in place which suffice as mitigation strategies, and they can just report them on the platform, and it's enough. You don't need to go any further. So the platform is, if the platform service is to say, okay, let's do a risk assessment, let's have our mitigation strategies, let's be able to, and at the end, at all points, you can kind of you can download the PDF or the report, which maps all of the risks, all of the risk assessments, etc. So it's a kind of it's trust at scale. So one of the advantages is that most companies that we're working with now have got lots and lots of algorithms, so they want to be able to do this in parallel. Want to have a kind of stable, centralized, almost inventory of algorithms, and to be able to search them quickly, etc., etc. And the platform provides all of these services. So it's usable. It's very usable from a kind of executive level and data science level. It's useful in terms of mitigation, and it has all of the kind of reporting aspects to it.
So I suppose at that first level, that's a great tool for people who are probably almost just uncovering the fact that they're using dozens of these algorithms and probably don't even necessarily realize that their digital estate includes this, some of which might be third party, some of them might be in-house. What have you done so far to look at that kind of, you used the phrase robustness. I often think of efficacy as a similar thing about actually, okay, well, we've identified that we haven't got any big risks here, or that we can mitigate them, but what are you doing in that kind of area of robustness and efficacy?
Yeah, so this is really interesting because most of the time when we engage with a data scientist, that's what they're interested in. And what we do is we identify whether or not efficacy is a risk. So you can have examples where, let's say I've got a system which is I think this was an example from the EU legislation actually. Let's say a spam detecting system. A spam detecting system that doesn't work that well may be annoying, but it's not existential. So so part of what we do is we actually identify whether or not efficacy is an issue in the first place. If it is, then there's a bunch of ways in which we can do assessments on just how, let's say, how you can do stress testing, for example. There's ways in which we can act in the robustness context that can improve the efficacy of the system. But I think it's very important to point that that risk is absolutely important, the operational risk. But we're not here to necessarily to provide them with algorithms, to build algorithms on their behalf. It's very much to identify that that's a problem, and then show ways in which to address that if it requires being addressed. So efficacy is what everyone's interested in terms of when you're using a system, it has to be useful. But we need to identify whether or not that's the kind of risk that sits in the broader governance of risk management.
And I suppose the irony is that because algorithms are so kind of perhaps narrow in their efficacy, that you're into that subject matter expertise issue of, well, if somebody's got a model here to do something very specific, as often is, you need that subject matter expertise to help establish robustness and efficacy, don't you?
I want to just you made the point about, when do we do this, or when does that become useful? Something that we found is one of the things I think we do, which not many people, I don't know if anyone does, is we can do risk assessment at conceptual stage.
Hmm.
And so at origination. And that's useful from two fronts. One, when it's being developed, to say, okay, what do we need to know at the start, what kind of risks are going to be associated with this, and build accordingly. It's much more cost, it's far higher to address post facto. And the second area is in procurement. So when you can do this risk assessment for systems that are being procured, and the result of that is we will put clauses into the contract of the system being procured to ensure that its robustness, its efficacy as at a particular point, it has provided, let's say, the debiasing tools, etc. And then the liability is on the company, and at least the company procuring is much more secured. And we found that to be very useful for customers.
Yeah.
Andrew, it's like the amount of money it costs on some of the systems after you paid for it and all of the various legal agreements. The company that sold it says, okay, the vendor says, we have IP concerns, so we can't give you access, or we can't do this or that, and you've already paid for it and so on. So
it's
the
all too
cost
late.
so the cost of the cost of getting it wrong is very high, especially in these kind of systems.
Indeed. Now, obviously, you're looking at lots of different sectors, and obviously, from our RICS's perspective, we're interested in both use cases that might be very specific to our sector. I mean, an example is the various automated valuation models that are out there. But obviously, as a sector that are just running generic businesses with things like recruitment and facial recognition on sites, I mean, what sort of mix of use cases have you kind of bumped into, to use the technical term, while you've been out there?
Andrew, the most interesting thing about this space is that everybody is using algorithms in a way which is sometimes less. So we've been surprised at how much interest there has been in this. So there's a lot of use cases. We've done use cases in financial services, and in financial services, the use cases have been more to do with the kind of public-facing sides, not the trading context or financial services. That's been things like credit scoring. It could be, for example, onboarding of customers, using facial recognition. Recruitment is really hot, hot sector for us because it's just so sensitive. We've been businesses that use different algorithms. We've done different assessments. So we've done assessments on marketing systems. We've done assessments on pricing algorithms and so on. So it's really across the board. We've done some public sector assessments. I'll refrain from talking about which sectors they're in, but really very interesting spaces and lots of assessments in ways that I didn't anticipate were going to be used. So that there's risk assessment algorithms in particular sectors, and we do a risk assessment of their risk assessment algorithms. But it's really interesting because you're identifying vulnerable groups, individuals, and this has really consequential impacts on people's lives. But in a more commercial sense, what we found is, despite the high-profile cases of bias, which is what everyone talks about, most of our work is really about assuring the efficacy of the system, as you've described. So the example that you gave of, that automating valuation and things like this, you can imagine how significant that kind of system is.
Exactly. I mean, it sounds a bit, in terms of your experience of what you're seeing in the marketplace, I mean, have you been surprised at how widely algorithms are used? I mean, it perhaps is a cliche, but is it from the perspective of the person in the street? I guess we don't really realize how pervasive these technologies have become.
Yeah, I mean, the thing is, Andrew, people think algorithms are, killer robots or like the kind of Terminator context. There's a much more benign use of systems, just to triage information, to do like your chat when you're speaking to the bot on like a food delivery service. Like most of there's almost a ubiquitous adoption of algorithms, but they're not as they're much more benign than I think what people think
Yes.
that they are. But they're not benign from the kind of from the commercial sense, in terms of these systems have to be, they need to be trustworthy, they need to be usable, etc. What we're finding is in the market space in terms of demand is there's a tension, Andrew. Sometimes when we made, very early on, we used to make a pitch about, look, regulation is coming in, there's huge reputational damage, there's financial damage through fines and the reputational damage and so on. But what we found is that most of our customers are they're usually B2C, or they're kind of public facing, or they have customers, and they're interested in customer care. So it's a much more positive story. They want to be kind of early movers, and I anticipate legislation to be coming within the next year or two. But a lot of the movement now is some of it's ECG, some of it's like people saying, okay, let's get a grip of this. So there is the kind of carrot and stick sides to the acquisition of our platform and services. But the big, let's say, the way in which we do it is we usually just do a case study, we do an assessment of a single system, and then we just show how it works. And then we say, look, we can do this at scale. There's much quicker way of doing this, much better way of doing this than just commissioning an individual assessment. So what we're seeing actually, because it's early on, we just build trust. There's lots of companies that claim to do things and they don't really do it. So it's just very much about just that at this stage, some of it's a bit hand holding to say that, look, let's do this assessment, let's show this, and let's show how it can be mitigated. And look, you can use this. So one customer, a very big customer of ours, is saying we have to, significantly increase the use of automation, but we need to be able to do this in a way where we can manage the risks. So it's not just it's very much an operational a way in which to actually increase the use of the systems.
Almost on that, in that vein, almost as a last question, and this has been fascinating, and I look forward to our next discussion where we dig more deeply into this. Given that there has to be, to some extent, to use the phrase, humans in the loop still, what's your view on where the human being plays a role in, perhaps supervising is the wrong role, but still being the wrong word, but still being involved in these processes, both from governance and also the operational side? Do we let these algos just simply do everything, or what is the role still of people in this piece?
So this is such an interesting space, because what I'm supposed to say that aligns with all of the kind of public literature is, oh, we got to ensure there's human in the loop, we've got to make sure that there's as much human decision making, and so on and so forth. But there's a paradox there, Andrew, which is, so how do we who's the human in the loop? And what's the human role? Like, as in, especially you can take some high profile cases, those recruitment algorithms which are biased are based on historical data, which was human decision making. So if you say, oh God, I've got a system here, here's some recommendations, and then I'm going to pass it to a human to say yes or no. I mean, what have we done then in our automation? And how are we confident that a human is not the same kind of human that was generating those data points that we've used that have rendered the system biased and so on and so forth? So what we found is it's great to have human in the different kinds of interventions. Some systems should be fully automated. It would make no sense to have a human in the loop or human oversee in the context of a spam detection service. In the context of recruitment, in the context of much more high profile or high impact on an individual, it seems that it would be foolish for us to just have a fully automated system. But really, it's about caveating the nature of who is the human in the loop. What is the human? Is that person sufficiently trained? Are there mechanisms? So one of the good things about the EU regulation is to suggest that there should be 2 sign-offs, and that the reporting should be done with respect to how the person has decided accordingly. So it's a very interesting space. There is the great issue, or the big risk of what we might call automation risk or rubber stamping. So let's say I've got the system generates 100 recommendations, and then I pick the first 10, You know, it would purportedly have been overseen by a human, but really it's just effectively automated. So it's a big area. I don't want to just jump on that bandwagon.
No,
Or
no,
really
exactly. I mean,
show that there's plenty of things. It's really, I think we've had this conversation, Andrew. It's very,
yeah.
you know, very difficult problem to solve.
Yeah, I can't remember the Latin, but you know, who watches the watchman? I suppose it's part of the overall governance framework and understanding where there is human involvement, how in itself is that governed in a way that doesn't simply just put back in unconscious bias that you removed by actually having an algorithm to do it. So I suppose it just has to be considered in a similarly serious way, doesn't it?
There's an opportunity here, Andrew, and I think this is such an important point to mention. There's an opportunity to address certain things.
Hmm.
So I was talking about this in the context of the EU regulation, and I was asked to present in the context of some regulators. And I was saying to them that I think we've got currently the most in the UK Parliament. We've got the most amount of women we've ever had, and I think it's at like 35% or something like that. And I was saying, look, you can have all these sophisticated explanations, sociological explanations, or as to why is it 35. But just saying that we've got 35, like the statistic is very striking. It's very strikingly low, in my opinion. So one of the interesting things about the opportunity here is that these algorithmic systems are going to spurt out these results that are very nakedly one way or another. Like it looks dodgy that this recruitment algorithm is taking 10% women.
Yeah.
Maybe we do need human expertise and understanding why that's the case and so on and so forth, but something striking about that. And what happens, I think, sometimes in these automated systems is that it very much surfaces the result or surfaces the assumptions and surfaces the kind of the biases in a way that I don't think traditional systems have done so. So I see it also as an opportunity, Andrew. I really do. I think there's something striking about the A-level fiasco when they were using
Exactly. Yeah.
algorithm. It was like, okay, it's quite nakedly biased. And then the automated system renders that the case.
Yeah.
You know, so there's an opportunity here as well.
Yeah, I think you're right to mention that A-level one. I think it was fascinating because for me, it highlighted the weakness not of algorithms, but of the people, dare I say it, putting them together. It was yet another human
Absolutely.
failing. It wasn't computer error at all, really, was it?
Yeah, absolutely. That's exactly it, Andrew. And it's a funny thing because, and here's a plug, if they had used our assurance tool, our governance tool, our risk assessment, there would have been big,
Yeah,
there would
big
have been
red
at
lights
least,
flashing.
yeah, like, hang on a minute. So yeah, so there's a kind of, yeah, there's a big opportunity here.
Yeah.
I really want to, you know, if you will, I really want to highlight the advantages of digital transformation, of algorithmic adoption. I think these are massive opportunities. And I think that one of my criticisms of the EU legislation, and I hope we don't do that here in the UK, is that it felt like they were conceding that these systems are going to be built elsewhere. And if you want to use them here, they have to satisfy these conditions. I'm like, no, we have the best scientists in the world. We have the best engineers in the world. We're leading in this field. Andrew, I can't come out of UCL Computer Science, UCL's AI Center, and not see that and think,
Exactly. Yeah.
you know, come on, we can do this. This is our industrial revolution of our generation. We can really make this happen. We have all of the talent. Let's take that attitude. I'm really uncomfortable with that all of our intellectual capacities and our labor, our talents didn't just go to the, say, Silicon Valley. Or I think we can really be that the UK can really lead in this space, and we've got legacies of, let's call it kind of reasonable. We've got a brilliant legacy of kind of pragmatic legislation.
Indeed. Yeah. Yeah.
So I just think let's get this right, and let's continue that legacy. So I think the UK, I think we should be the leader in this space.
Well, on that optimistic note, I'm going to say a big thank you, and I look forward to our next conversation. So once again, thanks, Emre. That was brilliant, and look forward to talking to you again soon.
Thank you, Andrew. Thank you.
Cheers. Bye now.